All right, here we are. This PowerPoint presentation has many iterations. It's about 35 slides. I've got a total of 45 minutes for my presentation. I'm going to go through them as quickly as possible, and so we've got some time for Q&A. But certainly we're here today at ConnecTech. This is a great organization to help bring everybody together with all of our technologies and our entrepreneurial spirit to build businesses. And what I'm going to talk about is how Michigan and America has the opportunity to lead the world again in industrial development. So what you see here is the Interstate Traveler hydrogen superhighway system. It is a system that's designed to upgrade the entire U.S. interstate highway network. The Eisenhower Interstate Highway Network is 54,000 miles of highway, right-of-way, that's about 300 foot wide. Of course, without President Eisenhower, we never would have had these highways, and our country never would have grown up into the powerhouse that it is today without those roads. So our highways are the arteries of commerce, if you will. And all we're doing is upgrading those highways. We're not disturbing the traffic. We're adding 2 new lanes of traffic that do 200 miles an hour. So what is the Interstate Traveler, this hydrogen superhighway? Well, yes, it is a transportation system, but it is so much more than just a transit system. It will become the largest solar collection grid in the world. When you have rails going down 54,000 miles of highway that are covered in solar panels, you end up with about 2 acres per mile. So that's 108,000 acres of solar panels just on the rail itself. That same network will have 22,000 traveler stations where people get access to the system. They will all have solar roofs. All the vehicles have solar roofs, and there's other systems we will add. All of this works because it has an embedded municipal conduit system. What that means is that inside of the box beam structure itself of this rail, we have a collection of conduits, which are used for water, for sewer, for electricity, for fiber optics. The electricity is actually superconducting cables, which are made here in America. And some of the larger pipelines are dedicated specifically to hydrogen. So this pipeline network will actually create and distribute hydrogen to every single gas station along the interstate highway network. We will be putting little tiny pipes underground to every single gas station, and you'll have, your regular gas or your diesel, and then there'll be hydrogen, and then there might be natural gas, propane, whatever it is you want to buy. It'll all go through our pipeline conduit system. Hydrogen production and distribution is the thing that everybody says, oh, it's the chicken before the egg or one or the other, and that's why we don't have hydrogen-powered cars. Just as a side note, all of our cars out here are already hydrogen-powered. If you didn't know it, hydrocarbons, the reason they call gasoline a hydrocarbon is because it's hydrogen mixed with carbon. Carbon doesn't burn, hydrogen does. So when we're driving our cars around, hitting the accelerator, we're actually burning a hydrocarbon or hydrogen mixed with carbon. So every car out here today can be converted for less than $200 to run on hydrogen. Energy storage and distribution is something that's also very important. 2003, millions of people in this country were without power because of a small cascading failure that took out, 15 states, part of Canada. I was without power for 5 days in Whitmore Lane. When power goes out, the country stops functioning. Banks stop working, ATM machines don't work, water systems fail, sewer systems fail, your refrigerator stops working, you can't cook your food, and then all of a sudden chaos starts to result. So having this system in place prevents that type of a cascading failure from happening. So energy storage is something we do very well. And there is no real energy storage system in the United States, except for Puerto Rico because of the military bases. Wireless internet access. This rail system is made out of stainless steel. It is a giant broadcasting antenna. So wherever this thing goes, we provide wireless broadcasting for internet services. And notice that millions of tons of stainless steel go into its construction. To put it in perspective, in World War II, the United States burned about 80 million tons of steel. A lot of it's still sitting on the bottom of the ocean. What we will do in about the same amount of time is use about 800 million tons of steel in just building the Eisenhower Interstate Highway System alone. That doesn't include all the steel that goes into building all the traveler stations and everything else that goes along with it. So this makes the steel industry literally go exponential compared to what they have done in their best years. And that, of course, means thousands and thousands of jobs. So here's the standard rail in the conduit cluster. The base configuration is the most efficient use of materials to provide the greatest structural capacity for load bearing. It's a box beam kind of turned on its corner. And it's all made out of 1-inch stainless steel plate. So once the thing is built and set up, it will stand and operate for hundreds and hundreds of years without any failure. It's not planned obsolescence. It's planned public infrastructure that we're not having to replace every 5 years. It's very important to do that right the first time. Certainly metal fatigue is a reality. There will be areas that rail sections will be replaced more often because of the traffic, but that's all built into our system. But notice that on top of this rail, there is these solar panels. It's 4 feet per side. So you end up with an 8-foot wide solar panel over the top of the rail, just the top of the rail, not counting any other surface area, which we will add. But that's 8 feet per rail. You put it down both sides of the highway, that's 16-foot wide solar panel. On 5,280 feet, that's 84,480 square feet, or a little over 2 acres of solar panels per mile of rail once it's installed. And notice again the conduits. The 2 larger ones here are actually 30-inch diameter pipes. So when we install it down the interstate highway, there will be 4 30-inch diameter pipes filled with hydrogen, which is a storage and distribution network for that valuable gas. Point to make about the solar skin. It doesn't matter to us what kind of solar panel is used, whether it's crystalline matrix, amorphous, or the new carbon nanosphere stuff you paint on with a plastic substrate. It doesn't matter. As long as we get a minimum of, say, 8 watts per square foot, we can hit our base performance numbers and have energy surplus. And we know by the time we go into production, we're probably going to have something like 20 watts per square foot, which is better than 3 times our base number. So all the numbers we might talk about today can be doubled or tripled in their potential. The 3 primary travelers are, of course, passengers, automobiles, and freight. One of the very exciting things about this public infrastructure is it is public. This rail system will be on the public right-of-way, and you'll have the same right to access as you do the highway system. Albeit, to drive a car, you got to have a driver's license. To ride the rail, you've got to be a registered rider. That's okay. It's a matter of safety and all of that. But you can own and operate a car on this rail system, design it any way you want, as long as the motors, which you see on the bottom of these cars, are all standard. These slotted linear motors, you can have 2 of them, 4 of them, 6 of them, 12 of them, depending on the size of the vehicle. So anybody in this room will have a chance to own and operate a vehicle on this rail system. Let's say, for instance, you own one of these container things. Let's say you've got a few semis, and that's your business. You move containers. You might own a few of these things, and you'll be able to ship containers across the countryside at 200 miles an hour. Since we're dues-paying members of the Transportation Club of Detroit and the Detroit Intermodal and Ocean Freight Association, we've already got the guys with the container ships, and they all know and understand what this will do for port efficiency. When I went through the grist mill at Ford Motor Company, I was a guest of the Advanced Research Division a number of years ago, and they all agreed that we'll probably build more of these than anything else, because America is an auto nation. We all have cars, and this is the car for your car. You drive into this thing, and the doors close, you're in a completely enclosed and safe environment, and you, your car, your family, in your own personal space will be able to travel across the countryside for 200 miles an hour. Imagine being able to go visit family in another state. If you want to go skiing, it'll only take you a couple hours to get to another state to do that. Of course, actually I'll go back. You might have a bunch of friends with Harley Davidsons, snowmobiles, horses, bicycles. You can all rent one of these things and go for a ride and enjoy some other part of the country. Securing the vehicles, this is the active floor restraint system. Very simple mechanism. Each of these hexagonal floor pegs have a pressure sensor. So no matter what type of car you have, how many wheels you have, or how big they are, you pull in, park sideways, cock the wheel, whatever, it will always feel where the car is and create a wall around the wheel so that somebody's not going to try and drive out in front of this thing while it's doing